All right, guys, welcome back to Math Analysis for Tuesday. So we are going to pick up right where we left off in the previous video, asking, there are 3.0 moles of NaCl. Now, what's NaCl? Think about that. What is that? Table salt, right? Just regular old salt. Now, how many sodium atoms are there? Or it says ions, technically, in the paper. That's not anything different. An ion is an atom, but an ion has a positive or negative charge to it that allows it to bond. And what happens is for sodium to bond to chlorine, it has to have that slightly altered charge for them to kind of pair up and attract. But ion, atom, we're talking about the same thing here. We would have gotten into all that kind of stuff, ions, into more detail, had we actually been in class, but sadly we're not. So here's what we want to think about. Is every molecule of NaCl sodium? Well, I mean, there's sodium in it, but there's not just sodium there, right? Not just sodium. So here's what we have to figure out. We have to think about what is the chemical makeup of this molecule and how do we use that chemical makeup to determine how many ions or atoms of sodium are present in 3 moles of this. So here's the really crazy part. If there's 3 moles of NaCl, a bonded molecule, then that means there are 3.0 times 6.022 times 10 to the 23rd atoms, or molecules here, right? 3 times this number of salt molecules. So 3.0 times 6.022 is going to be 18.066. If my math is correct, and I think it is, I hope. Times 10 to the 23rd molecules. I'm going to alter this number by moving that decimal place over 1 so that it's a little more properly written scientifically into 1.8066 times 10 to the 24th NaCl molecules. So here's the deal. If we have this many salt molecules, and each salt molecule is made up of a sodium and a chlorine, then how many atoms of each of these are there? Well, let's look at it this way. A sodium or a salt molecule is made up of a sodium and a chlorine. 1-to-1 ratio. 1 sodium, 1 chlorine. Not any of those crazy ones where you have multiple of one but some of another. So in this case, then we would acknowledge that if we broke this up, right? If we broke this apart, then we would have this many salt molecules and we would have this many chlorine atoms. Sorry, I should be using the term atoms whenever we're talking about a single element and molecules whenever we're talking about a compound, but sorry. So if we broke this apart, then we have 1-to-1 ratio, right? For every single one of these salt molecules, we have a single atom of sodium. So that is a 1-to-1 ratio. So that means this is how many sodium atoms we have. This is just simply the answer to that problem. Now, if we look at a different kind of situation, number 8, for example, on this paper, let's take a look at it. It is how many total atoms are in 1.0 mole of H2O. Here's what I'm going to do. I'm going to alter that question a little bit, okay? Let's say we have 2.5 moles of H2O, we want to know total number of atoms and the total number of hydrogen atoms. Now remember, I said there's a specific difference between atoms and molecules, and I'm going to do my best to make sure I'm articulating that well here in the future. But an atom is a single element. A molecule is the term for a compound. So something like NaCl is a compound or H2O is a compound because it has multiple single elements combined together. So whenever we're talking about atoms, we are talking about individual elements, single ones. So here's what we want to do. What we want to first work out is if there's 2.5 moles of water, of H2O, then how many total molecules is that? Well, 2.5 times 6.022 times 10 to the 23rd. 2.5 times that number, I'll have to figure out what that is. That is, let's see, 2.5 times 6.022, 15.055. So we have 15.055 times 10 to the 23rd. I'm going to move that decimal over to be 1.5055 times 10 to the 24th molecules. And again, the terminology here is very important. This is how many molecules of H2O we have. But here's what we got to think about. This is where it gets a little different from the salt example. If we have this many molecules, and a single molecule is made up of H2 and an O, so 2 hydrogen and a single oxygen, then how many atoms are in every molecule? Yeah, we have 3 atoms in a single molecule, right? There's 2 hydrogen and 1 oxygen, 3 atoms. So if there's 3 atoms in one molecule, and we have this many molecules, then how are we going to figure out how many atoms we have? You got it. Multiply by 3. So 3 times 1.5055 times 10 to the 24th. Let's see what we get there. We have 4.5165. I'm going to write that together. Did I write that in the right order? Oh, I switched the 1 and the 6. Darn it. Okay. This is what we have. That's the total number of atoms, right? That answers this question right here. That's the total number of atoms, hydrogen and oxygen combined. However, our second question is how many total hydrogen atoms? And that's what we gotta think again. Of the 3 atoms in every molecule, how many of them are hydrogen? 2, right? 2 hydrogen, 1 oxygen. So that means 2 out of every 3 atoms is a hydrogen atom. In other words, 2/3 of these atoms are hydrogen. So that's what we can multiply this by. We can multiply it by 2/3 to figure out how many hydrogen atoms there are. So if I want to multiply this by 2/3, then I get 3.011. Times 10 to the 24th as our total number of hydrogen atoms. So really, a lot of this is about thinking, what is the makeup of what I'm working with, Is it asking me for molecules, or is it asking me for atoms? How does that work, right? What do I gotta do? So again, we multiply the number of moles times Avogadro's constant to figure out how many molecules there were. We multiplied that number by how many atoms are in each molecule to determine how many total atoms existed. And then we took that and multiplied by the proportion of hydrogen atoms in that molecule to figure out exactly how many hydrogen atoms there were. We could have done the same thing with oxygen, but oxygen would have been 1/3, right? All right, well, that's what I got for today. No problems for you to try out. We'll keep on going. We'll see what tomorrow brings. If you have any questions for me, let me know. Otherwise, see you guys then.